So let's try to get that cleaned up in terms of the edge recycling and stuff like that, because this is something that, actually I gotta go for a coffee. Wait a second. Cool, coffee's here, that's good. So let's try to see if we can clean that up. It really seems like we have to have at least, it really seems we have to have at least one edge, which is the system edge. Next, documentation. Struggling with that though. But okay, so let's take a look at print system. Instead of drawing the system, let's first try to print it. Okay, so print system. See if it's healthy, so to say. I just need to have a print system. Okay, so print. We'll just do something like this. Okay, so that's the whole system, blah, blah, blah. The edges, I think I don't have to. It's not the whole system, like, no, that's the whole system hypergraph here. So, okay. How can I print that in a nicer way? It's just that's bothering me a lot. It's not easy. So we have a system edge, which basically is empty, and that's bad. But it reflects these here. That's so messy. We have an edge. I kind of like it more like these, where we keep the qubit as an attribute of the nodes and not as an edge. Then we have an edge 53. Which is empty. I haven't solved the amplitude problem yet, but okay. Yeah, this all looks fine. Now, what I want to do, so I want to clean the edges, right? What I know for sure that I have to do is as I merge, I should clean the edges. But I mean, it's part of the merging, right? So because what this is doing is, it applies these, and then it gets a new state, and then what we're doing is it's creating an edge per. It's creating an edge per. Maybe I should turn that into a loop. So because what I should basically do is for I in range like 0 to 3, right? Because it's so this can be generalized by n qubits, but like this is hard coded for 2 qubits. We know it's going to have 4 elements, right? So at the end, what we are doing is we should calculate this probability, right? And then we should say, so that's I. And then we should do these, right? And say if, what am I doing? And I should say if prob, then we create an edge, right? So that's an edge. Like edge I, so to say, right? Edge I, and it's got this amplitude. then we add this to the system add edge I, and then we create. So we create the P and the Q nodes, and here what we have to do is we have to basically, I think this is just, yeah, so this is where this is kind of dependent on I, right? Since the it's the binary representation of I, and I should have a nicer way. I should have a nicer way to do that, but so what I would do is what is qubit 0 and qubit 1? Where is it coming from? Oh yeah, there, here. Okay, cool. Now, so here's where if I is so if I is even, right? So I would just basically say so this is P and this is Q. So this should be 0, 0. So this should be like, can I do something like if I is even, then initial state, otherwise is it excited state or excited state? I think that should work, because that's the second qubit. That's the, yeah, exactly. And in this case here, we want a 1 for, so we have, so we want a 1 only if it's bigger than 2, right? So this is the even case, otherwise it's a 1, and then we want a 1 here if it's bigger than 2. So so here is like if I is bigger than 2, is bigger equal than 2, 0, 1, 2 is bigger equal than 2 is bigger than 1, then we want yeah, that's stupid. So if, because the modulo will be 0 if it's even, so I can just flip that. Excited state, initial state. Right? Because if it's even, this will be 0, so it will be false, and so it will go here. If not, and then if I is bigger than 1, then we want the excited state, and then we want the initial state in here. Okay, that should work. And then what we need to do is we need to add these. We need to add these to edge I. That's going to keep the code a bit cleaner. P and Q. And I think this means that we don't need all that anymore. Let me just comment that for a second, make sure that it works, right? So we yeah, because remember that we want to have, the thing is I want to also create the, I want to make sure that I create the branches that that also have probability, like amplitude 0, and then we need to deal with them, right? So that's kind of another thing that we have to deal with. But that should be make it a loop, so that should make the whole function easier to process and easier to debug. And then we clean up. So we clean up the nodes. do we don't want to use, right? Which are the ones that we've actually received in here. We just need to clean them up. Now, the thing here will be when we're doing these on an edge by edge basis, because we're creating new edges, I might also have to. Okay, so and this is where this goes here. I might have to clean up the edge. That's the one. That's what we should be working on now. But let's test if this works. So I'll just comment all these for now. Because what only we want to do is from state vector and apply the hardmark gate, and then I want to apply, these. Okay, sorry. So then I wanna get all the qubit nodes and apply these. And these I think I'll have to change as well, because yeah, okay, whatever. So I'm applying a CX. Yeah. Yeah, exactly. That's the easiest case because we know it's just the system, right? But actually, if there's no edges, I'll have to actually get everything from the system edge. Now I'll probably be doing this next, but let's see what happens. Boom, that doesn't work. So inline conditionals in. Why am I on this browser, by the way? Let me just take these away for a second. And actually, get these in here, and then say conditional, not inline inline conditions Python inline if statements. Is this all working well? Cool. Autosave, so I can just close here. Now I'm back here. Let's make that a little bit bigger. The code is still readable. Trailing it, two kinds of if statements rather than if condition statement, if condition block. Okay. So expression if true, if condition else these. Okay. So I guess A if B and else 0. That's what we need to go for. So we need to say yeah, I don't know. I think is that from JavaScript or something. So I think what I need to do is excited state if these else initial state, and then here I need to say excited state if. Yeah, actually it's quite nice. Else it's quite a nice way to write these. Else initial state. So okay, what do we have here? Something's not right. Something's not right. 0, 0. That's, oh yeah, that's definitely wrong, but it's something's really wrong here. 3, that's the 1, 1. Oh no, actually I'm ignoring the branch. I see that. Okay, cool. I'm ignoring the, if the probability is 0, I'm not creating the branch. So it's the excited state if I is bigger than 1, else is the initial state, so 0. And it's the excited state if it's, if this is not 0. I can also try, no, but that should work. Because if modulo 2 is 0, then it means it's even. And we want that for 0 and 2, right? And 0 divided by 2, it's 0, right? Yeah. So what is wrong here? What is wrong? What is going on wrong? So let's first then let's ignore this for a second. Let's see what happens. So we have a system and we have a node in the 0 state and a node in the plus state. That seems correct. Cool. It goes wrong when we apply these. So if I print, I think that is correct. If I apply the gate, CX gate, what is happening here is I'm getting the nodes, and then I'm creating a node. So first of all, let's print the new state vector, right? Because we want to yeah, okay. It's the 0, 0 and the 1, 1 exactly, because that is then 0, that is then 0, so that's correct. And so we have here a system edge is empty because that's the problem here. And then I have a new edge which connects both nodes for the 0, 0, but there's no missing one edge for the 1, 1. I'm missing I'm missing one edge. Why am I missing one edge? That's what I'm missing. So print prop. Yeah, I know I shouldn't be doing this right now, but like, okay, so probability, it really just prints it once. What about what about 3? Oh, maybe I need to. Oh, maybe I need to add 4. So that's like it does 0, 1, 2, 3. It has 4 elements starting from 0. That's probably the way that this is read. Oh, there you go. Okay, so now you have two nodes, the 1, 1, and 0, 0. Okay, cool. That works. Nice. So I think I can get rid of all these now. That's always satisfying. So this is now much, it's cleaner and nicer. So how do we do this with the edge thing now? So this essentially what it does is it takes, the thing is it always takes an edge, right? And it creates like a given amount of new edges, but then it cleans up that stuff. So the problem is I need to maybe the system edge stays there empty. Maybe what this means is that in the system edge we're going to have qubits which are not entangled. I don't know if that's going to be something that is bothering. Maybe that's going to be maybe an easier way to I don't know. I kind of not like these though. Should still all belong to the system edge, I feel. And I think I should just always, when I create a node, I think they all always, yeah, I think by default they should all be, added. Create node, create qubit edge. I think I should always give it the system. I should always give it the system, the state vector, and the qubit, and it should always do system add node to edge system. Should always add it to system by default. And now I have to fix all the other. So it's going to be system, right? Okay, so I don't need to actually so I need to actually that's important. So I need to first I'm creating the system edge, then I'm creating the hypergraph, then I'm adding the system edge there, which is going to be empty. And then I create the nodes, right? And by default, and I don't really need to care about these, so that's nice. So just by default, what it does is it adds them to the system edge. Can I just, why is my keyword not working well? Create node system, blah, blah, blah. So I need to create the node. I need to create the, system. And we still want to add it to these edges, right? So that's why we get the node back, new node. So we also want system in here, and I think we're done. System. So that should always cool. So that should do that should do the trick at least. What is going on? Why is everything so slow? Why? Cool. So bum edge. So there's something can I just give it the so HNX documentation. Can I just give it the key to the edge of the edge? I thought I could just give it the key to the edge. From state vector. entity system, add edge. Oh, no, what is wrong here? What is the problem? Add node. So hypergraphs, add node to edge. It needs the node and the edge. Okay. And I think I've done it like add node to edge. Node and edge. That's what I was missing. Okay, cool. That works. So we've got the system in here, and yeah, neat, perfect. And that still works, right? So it's got 4 nodes, amplitude 1 and edge 2. And if I print, yeah, whatever. That's all good. That's all good. I think, again, I think the trouble with these nodes being actual copies of the other nodes, and the sort of the internals of the implementation here in terms of whether the states and stuff are all up to date. Like, I don't know, we'll see. We'll have to keep an eye on these, but I should probably install an updated version of HNS because they really fixed it. So thanks a lot for the team there. They really fixed the issue with adding the node to 2 edges that was kind of creating the qubit thing to be lost somehow. But now, okay, that seems to be working. So okay, cool. And now I'm supposed to clean the edge, right? Because now if I go and I actually do these, so I've applied now this operation, and now I'm going to apply the other operation, which is basically okay, no, I'm not going to yet let's not merge yet, so this is still work in progress. Let's now apply the next operation, which is for each edge we want to apply a controlled NOT gate, right? So no, what is going on here? That's the merging. Man, I'm a mess. I'm a mess. So this is not merge hyperedges. So this is now CX gate, and this is now get entanglement edges, and for each edge, get the nodes, control the target nodes, and second CX gate, and this is merge edges. So, and we apply the CX gate here for each of these edges and see what happens, right? That's the goal. Okay, so what's wrong now? Nodes, remove element. Key error, nodes. What? Target nodes, so edge elements. Oh, okay. Yeah, we don't want. Okay, no, but the edges will be the ones. How did I implement that? if it starts with an edge, that's an entanglement edge. That's correct. So we take a look at these edges and then we apply the 2 cubic gate. And so what does this mean? We apply the 2 cubic gate. Okay, it happens in the removal. And it breaks because key error nodes, self UID nodes. Why? Why is nodes in there? What? The key at all? I mean, I guess what we have to do is print control nodes, print target nodes. I guess something's off with the node that nodes. No, that's seems to be correct. So let's go inside the function in here. Let's see what happens. So in Q0 nodes, da 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 da. So let's print. Let's print the Q0 nodes. And let's print the Q1 nodes. So that's all good. I mean, what's wrong? Remove node. Self nodes remove entity remove element. And then it says key error nodes. And delete items, memberships. Why is that a problem? Let's see for which this happens, for which node is it Q0 or Q1? It's in Q0. Okay. So print Q0 and node 41, node 44, and then it breaks. Why? So print system and it breaks. And here we have system. It's a hypergraph. System has all the nodes. 55. I need to definitely clean those nodes. I mean, if I don't clean the nodes, then I get these stuff, right? Which oh, wait a second, there's a node here. Why is this node there? Node 63. And 64. Why are those nodes there? Oh, because I haven't cleaned them out from the first iteration. Yeah. But okay, I mean, What is the problem with these? Remove edge. It's just... So what if I keep these, because this is breaking, so what if I do this? Then it also breaks there. If it's instance of entity, then the self UID is nodes. Why? Why is self UID nodes? The heck? Remove element self item. Nodes, remove node. It removes the nodes from the nodes. Yeah, that kind of makes sense. Remove node. Okay, I know what happens. It's again the same problem. It does not know, it removes it from, and I think it removes it from one edge and then it doesn't find it in the other edge, in the system edge. I guess that's the problem. I guess that's the problem. I really have to get an updated version of HNX, I think. Because this is definitely... So, GitHub. HNX. There you go. I mean, did they merge these? Is this the one? Is this the one that I... issues. 5 issues closed. I think that is the... closed 5 days ago. Okay. So, but I'm assuming this is then merged or what? So I'm assuming that, and whatever newest version we're in, that actually, I can just uninstall this and install this. Can I try that? Can I just like conda uninstall or pip uninstall HyperNetX? Can I just do that? Can I say like pip, oh sorry, conda activate EHS for this PowerShell, uninstall HyperNetX. Does this work? Because I don't want to have to build that or something from the source. Pip uninstall. Does that exist? Yeah, seems like it exists. Yes. And then now we'll do pip install. Oh, maybe I should have refreshed or something the packages. HyperNet 0.3.7. That's the same one that I had before. And what is the version that is in here? How can I know these? I don't think it's been released, right? It's fixed, but it's maybe not been released. I'm such a noob with these stuff that I don't know. Releases, okay. The latest release is in September 8. Yeah. So, oh, it's 3.8. Yeah, but that's September. No, that's October 3rd. So that definitely does not include my. It definitely does not include my my fix. So I would have to. You know what? I think I should just do this manually, right? I think I can just say. So how does this work? So it removes the element. I think I should just remove the element from. Because I should actually go to the edge this belongs to and remove it from there. Come on. Remove node. Remove nodes. Node set. Remove edges. Maybe I should use remove edges. And that would actually clean up the nodes and the edges. Maybe I should try to do these, you know. Actually, maybe that would work better. What does it do? Remove edge. Remove edge. No, remove node. Edge remove node, and if. Yeah, so it tracks the memberships. And if it's 1, then it removes it from nodes. If not, it keeps it in nodes. The problem is the memberships might not be updated. That's the problem. And so I will remove from nodes, and then let's check memberships. Actually, let's check the memberships, because I think that's the problem, right? So the length. So let's check. I think that's the problem. It just removes it. I think it removes the membership count. I can probably tweak that by adding a membership myself. It removes. Yeah, how's memberships? So how does memberships look like? Actually, let's try one thing. I think I can just trick it. I think I can just trick it here by every time that I add it, I will add manually a membership, because I think that's what's happening here. So from state vector, create node, create node, create node, create node, add node to edge system. And now I'll just say no, not here. I need to take a look at the memberships. When I'll check. Where should I check? I should check in here. Exactly. So when I'm adding these to the nodes, and now I should just go and so for n in system nodes, print length of system nodes n memberships. Oh, let's update it. Okay, but not in the edge, probably. That's the trick, I think. So it's updated there, but it's not updated in the edge. So if I say for edge in system edges, edge equal system edges E, and now for n in edges members or elements, and now I do edges elements elements system edges in exactly that's oh no edge oh sorry edge dot elements, that's what I need to do. No, edge is like these, and then edge you get the elements, and then edge elements, that's what I do. Yeah, there you go. So we've got some ones in here. That's the problem. That's the fucking problem. So yeah. So the problem is the stuff that's fixed, but it's not yet released, which is that this thing here does not increase the memberships of that element within the edge, and I should probably and so when I clean up, then I should clean up, maybe I should just clean up from the nodes perspective. What I should do is I should because it's funny because it's like it feels like it is updated. It is updated when I take a look at the nodes element. And so system remove node, what it does is I don't want to have to build that, like build a code remove node. What remove node does is actually it checks nodes, and then it removes it from the edges if edge in node memberships. So that should work though. So why isn't it working? So when I do this, it does. So it's remove node, and then it doesn't find it in the nodes. Remove element. Something's really not working well with these. Oh god. So I need to actually build. Do I need to build it? I don't want to build it. Install. I don't want to build from source. I really don't want to. There are not even instructions on how to do that. Damn it. How can I get a patch for these? Maybe I'll just get in touch. Maybe just stupid, like I don't know how to. Because that's definitely an issue. So I cannot remove nodes now because of these. Is there a smarter way to do that? Maybe if I would remove the edge. maybe if I would remove the edge, the nodes from the edge. So I'm creating a new node here, and I want to remove these nodes from the system edge maybe. What if I would do that? So what if I would do remove node, add edges from, remove edge, remove edges. Remove node from edge. Like what if I would want to do that? Like can I do that? Remove node just has remove node, remove nodes. Remove node. Add node to edge. So it just maybe what I have to do is I have to increase this. So it's memberships, by the way. Memberships. So add node to edge. What does it do? Properties, blah blah blah. It adds it here. Where is the so add node? So also that's in the element add, so to say. Or do I need to add the reference to the system element? Add. Add element. Just add element. So it actually adds the full element. It's like it's a dictionary as well. Self. Memberships. Item memberships. Self UID self and self elements. So maybe if I would do control gate. Yeah, by the way, I think I can remove these. Apply control gain. I think I can remove these. Also, will make my scrolling a bit better. So I think as soon as I add this node to the edge, maybe here I should like memberships. The thing is, I Is that an element? Is like memberships an element of entity, or just something specific from? No, that's memberships. Yeah. Entity. Memberships. Yeah, memberships. So so memberships, and actually I should just use edge I UID edge I. So I should really, maybe that works. I don't know for Q. Like I'm hard coding these. This is a workaround. Okay, gotta open the door. To be honest, I don't know which is the membership that's missing, but let's see if that works. Let's see if that works. I don't know which is the membership that's missing. So what about these? So what about print? So print, man, memberships, and then print sort of edge I, print edge I. Now for node in system edges edge I UID node equals, you know, these and now print node memberships. So H 144 we have, oh, what am I? Oh, so it's twice the membership. Okay, so that's wrong. So I should add the membership to the system edge, which I know about, so it's easy to do. So I should do, where am I? Come on. Stupid. There you go. So what I should do is not these, but I should say system, and then I should say system edges system. So basically I'm just hard coding the fact that it still belongs to system. Oh no, but then, oh yeah, now it belongs to system and it belongs to edge. System and edge, and it still breaks. Beautiful. It's beautiful. So membership. So I don't want to print this here. I want to print N. So for node 167 we have a system membership, and we have an H166 membership. For node 168 system and H166. For node 170 we have a system and an edge 169, blah blah blah. So okay, but for node 174 we have just a system. Why? So what is wrong? Maybe it's not about these. What it's So if I don't do that, yeah, it just, you know, it kind of like, it doesn't remember that those elements belong to the system edge. Whereas the nodes in the system edge, they actually do have that. But still, I don't get, like I can hard code these, but then why does the remove node, why does the removal, why is the removal not working? I don't get it. I don't get why the removal is not working. It says remove node, and so what is the node? I mean, okay, maybe something's off with the keys in here, really. So print this stuff, print q0n, so print removing, and then so I'm removing node 197, node 197, node 100. Oh, it's just the name, right? This is really just the name. I'm just giving it the key. Am I? So what is in Q nodes? Print Q nodes. Q nodes. Node has says empty. Da 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 da. So it just has one node. And then with the, this is the node. Okay, and then let's take a look at the memberships of this node and see what happens and why does it break. So print memberships. So it's got a membership only on the system. Okay, so in here the node where this breaks is node 230, which has got a membership on the system and on edge 229. Edge 229. And this breaks because it says remove it from node. Remove it from the nodes, right? And so it says entity remove element. self item, self being the nodes, and then it says item memberships. Delete item memberships self UID. Key error nodes. I just don't get it. Key error nodes. Really don't get it. Sorry, I don't know. I have to figure this out. But it's something messed up with these. I probably have to contact the team again. Come on, it can't be that complicated. I mean, I'm just removing. I just want to clean up this stuff, man. I need to remove them, really. I really need to remove them. Unless I kind of have to go... I guess I'll just do this by hand. And I get the nodes. I will just go to the actual entities and just remove the element. Like, what do I have to do? I have to remove the elements. I just have to remove the elements from... I have to remove the elements from the original edge and from the system and from the system edge and from the nodes. Clean up edge and nodes manually by accessing manually identity level. That's it. That's gonna be the next. That's gonna be the next thing. Yeah, because I know I got to remove from nodes. Yeah, because that's definitely they're not being cleaned up. So yeah, okay, perfect, whatever.